All right, let's do a quick video on arithmetic sequences. So I'm going to teach you what they are, run through a couple examples. So first of all, an arithmetic sequence is a pattern of numbers, like this one right here, where there's a common difference. That common difference can be added to any term in the sequence and you'll arrive at the next term. So the terms here are 7, 11, 15, 19, 23. So you can see each time it's plus 4. So the common difference is 4. D is going to stand for the common difference, right? Now the terms, this is the first term, that's the second term, third, fourth, fifth, and so on, right? So that the terms are the individual numbers in the sequence, right? Another example is 1 3/4, 1/2, 1/4, 0, negative 1/4. So here, the common difference is negative 1/4 because you're going down by 1/4. So you're adding a negative 1/4 to each term to arrive at the next term. Now, for the terms themselves, I'm going to use this kind of notation right here with a subscript, like U2. So U2 would be the second term in this sequence right here. And here, U5, 1, 2, 3, 4, 5, this would be term 5, which we're going to call U sub 5. So that's how that's what an arithmetic sequence is, and this is how the notation works. Now, if you were to make a graph of an arithmetic sequence, it would be linear. It's got a slope because it's got a common difference between each and every single term. So the notation, just once again, U sub 3, that would be the third term. U sub n, that's the nth term, sometimes called the general term, and D is the common difference. Now, there's a super fancy, very important formula you got to know. You might even want to get a tattoo of this because it's super important. You're going to need it all the time. All right, let's get into a couple of examples, shall we? So our very first example right here, it says write the general term for this right here. 7, 11, 15, 19, 23, and so on. And then after we do that, we got to find the 50th, right? So the first thing you're always going to want to do, if you have a formula to use, write down the formula. So U sub n equals U sub 1, n minus 1, d. Now, n is the same as U sub n, right? So depending on which term you're talking about, this n and this n will be exactly the same, right? So here we know that U sub 1 is 7 and n minus 1, and we know that d is 4. So that's it right there. So we could check this, see if it works. So we know, for example, that U sub 4, the fourth term, is 19. So we could actually check it and plug in and see if this is actually equal to 19. 7, right? So 4 minus 1. So that's 3 times 4, which is 12, right? And 12 plus 7 is 19. So actually that deserves a heart. There we go, 19, right? So it works. So we know we have the right formula, so now let's do U50, the 50th term. So 7, that's U1, plus 50 minus 1 times 4. So 49 times 4, right? And then plus 7, so 6, 3, 19, plus 7, 203. 203, if I didn't make a silly little adding error. I don't know, I haven't done this problem before. I hope I didn't make something silly right there, but you get the idea. All right, so now let's talk about one that's a little bit more tricky. Example number 2 right here, it says we have an arithmetic sequence. The second term is 9, and the seventh term, well, that's 27. So that's a little bit uglier right there. We have to do a couple things right here. We have to find the common difference. Then we have to write the general term, and then we have to find the 60th term. So we should always start with our formula. So U sub n equals U sub 1 plus n minus 1 times d, right? Now, here we don't know d, we don't know n. We have to figure out how we can use these two things right here. So here's what we can actually do. We can say u sub 7 equals u sub 2 plus n minus 1 times d. Now, n is the number of terms between here and here. You might want to say it's 5, but it's actually 6, and I'll show you why. So if these are our terms, and we're going to start on 2, and we're going to go all the way to 7, look what we've got. That's 1 term, 2 terms, 3, 4, 5, 6 terms. That's n. n is 6. So u sub 7 is 29. I'm going to plug that in. 9 is u sub 2 plus 6 minus 1 times d. So now we have an equation we can solve for d, right? So this is 5, right? So subtracting 9 from both sides, we can see that d equals 4. So now that we know the common difference, we can actually write, this is part A right here. So now that we know that, we can go ahead and write the general term. So it's going to be u sub n equals u sub 1 plus n minus 1 times d, and d is 4, right? That's 4. So now we have to find u sub 1. So the way we're going to do this, the way we're going to do this is we're going to say, well, we know what u sub 2 is, right? So u sub 2 equals u sub 1 n minus 1 times d. Now we could plug this in right here, or we could just say, look, we're going by 4 every time, so we can obviously see that u sub 1 is equal to 5. But let's say we didn't think about that, and we're going to use our formula instead. So 1 minus 1 times d, right? Oh, 2 minus 1, sorry, 2 minus 1 because we have 1 and 2. So that's equal to 1, 2 things. So that's n. And so 9 is equal to u1 plus 4. So 5 is u1. All right. There we go. All right. Now, last thing. We have to find u sub 60. So the 60th term. So u60 is equal to 5 plus 60 minus 1 times 4. So just doing our calculation right here. 59 times 4. That's 241, or 236, plus 5, 241, u60. So be patient, use your formulas, plug them in. The trickiest part is figuring out what does n equal if we start on u5 and we go to u10. You might want to subtract and say that it's 5, but it's actually 6 because you'll have the 5th term, 6th, 7th, 8th, 9th, and 10th. So that's 1, 2, 3, 4, 5, 6. So you have to include the one you start with. All right, I hope this video was helpful, and make sure you just write the formula, take your time, be patient, and you'll get it.